Beginning its journey east from New York City, the train would first pass through an airlock, accelerating gradually for the first 750 miles. Taking a full 18 minutes to reach its top cruising speed of 5,000 miles an hour. Passengers would sit in pivoting, rotating seats, designed to further reduce the G-force effect. And since the train literally floats on a magnetic field, passengers would detect almost no shaking or jolting. Each car would be the equivalent of a sealed spaceship with its own pressurized recirculating air. At top speed, the train would actually travel faster than a bullet fired from a gun, covering 1,600 miles in the next 18 minutes. The final leg of the journey would be an 18-minute deceleration. The train would pull into London Station exactly 54 minutes after leaving New York. Less time than an hour's ride to the airport in rush hour. Power for the system would come from generators located at the two stations. They would distribute power to substations located in the tunnel's service tube below the guideway. It's an elegant if ambitious plan. But what if something went wrong? Fire is one of the biggest concerns for tunnel engineers. The smoke from a tunnel fire has nowhere to go, making these fires unusually deadly. For this reason, massive fire suppression systems would be installed in every car. A collision would also be catastrophic. Because of the great distances involved, there would be no way to extract passengers or wreckage. And what if a tunnel train had to make a sudden emergency stop? Could a train behind it doing 5,000 miles an hour stop in time to avoid a devastating impact? To prevent disasters, the tunnel would need to be continuously watched, monitored by a network of sensors. The network would instantly register any failure, large or small, anywhere in the tunnel. Computers would immediately switch to disaster mode and execute automated procedures to minimize the damage. But there is one scenario that even the best safety systems could not prevent. It's a scenario that, if it ever came to pass, could render the transatlantic tunnel a severed, lifeless artery. The year is 2099. On a busy Friday afternoon at the tunnel's New York terminal, the 5:30 train for London is just departing. 1,000 passengers on board are settling in for the short, smooth ride. But 800 miles out at sea, disaster awaits them. An aging nuclear sub has just lost navigational power. All steering control is gone. As the crew fights to fix the problem, one system after another begins to fail. The captain suddenly finds himself not only without rudder, but without visual and without sonar. The sub is blind and now completely out of control. And it's heading straight for the transatlantic tunnel. The vessel weighs 50,000 tons and it's armed with 16 nuclear warheads. A collision could be catastrophic. But as the sub comes within 2 miles of the tunnel, electronic motion detectors pick it up, triggering alarms at central control. Instantly, tethers closest to the vulnerable zone automatically slacken to allow the tunnel to sway upon impact. Too much sway is also a problem. If the tunnel is pushed too far out of position, the maglev guideway could warp, causing a disastrous 5,000 mile/hour derailment. The train and its passengers would be instantly vaporized. Back on the sub, the crew finally restores emergency power. It's too late. Just 200 feet now from the tunnel, the captain throws the engines into full reverse, while the crew braces for impact. The tunnel shakes violently, but it holds. The concrete and steel walls absorb the blow with only minor surface cracks. Incredibly, the passengers inside don't even feel a bump. At 5,000 miles an hour, they'd be miles past the point of impact in less than a second. And in a few days, a crew of divers will be out here to repair the surface damage. Yes, it is a happy ending. Of course, no one can know for sure unless the tunnel is built. A transatlantic tunnel. Nothing on Earth would even begin to approach its massive scale. Everything from the Great Pyramids to the Great Wall of China would be dwarfed in comparison. Yet despite its staggering cost and technical challenges, visionaries like Frank Davidson believe that one day it might happen.
Although a very difficult problem, the project is not at all as hazardous as flying to the moon.
If this tunnel were actually built, it would be one of the engineering wonders of the world, and as an engineer, I'd be very anxious to try it out.
What we forget is how far we've already come. The things we take for granted today were considered unimaginable yesterday. It seems to be our collective destiny to turn today's impossibilities into tomorrow's realities.